Okay, today we are covering the last lesson in Unit 1, which is going to talk about inverse functions. So open up your Springboard book. We are starting on page 89. Have something to write with and a calculator if you need it. So today our goal is to find the inverse of a function. So we're actually going to skip all the Springboardy stuff, and I want you to jump to page 91. Okay. So two functions, in this case we're just going to say f and g, are inverse functions if and only if their compositions cancel each other out. Meaning if I take f of g of x, I'm just left with x. All the numbers, all the operations, everything would cancel. Okay. Same thing if I took g of f of x. If we compose those functions and everything cancels out, we know we have an inverse function. Okay, so an inverse function just kind of undoes an operation. Just like if we have addition, its inverse operation is subtraction. They undo each other. Okay, and then we also use this notation here, f negative 1. Like negative 1 is kind of like a little exponent there. This here. That is the notation that we use to say inverse function. So f negative 1 of x would say the inverse function for x. Okay? So the way we find an inverse function is by taking these 3 steps. Okay, so if we have this function f here, okay, we're going to find the inverse by step 1, changing the f of x equals to y equals. So that's step 1. Okay, step 2, what we do is we just interchange the x and the y variables. So we just change their location. That's all we do. Okay, just kind of swap what happens there. And then step 3, we solve that equation for y again. So in this case, in this example, they added the 4 to the other side and divided by 2. Once y is back by itself, that means you found the inverse. So you know you'd stop working. Okay. So we're going to practice some examples here from the book. So in A, we have f of x is equal to negative 3x plus 8. I'm going to find the inverse here. So step 1 is to change this to a y equals. Step 2 says we switch the x and the y. So this becomes now x equals negative 3y plus 8. And now we have to do all the inverse operations so that y is back by himself. So we're going to move everything to the left side of the equation. So we're going to start by undoing the addition first. So I'm going to minus the 8 on both sides. Now x and 8 are not like terms, so nothing really happens with them besides changing to x minus 8. Okay, so we're still not done because y is still not by himself. So in order to get rid of that 3 in front, we just have to divide that out. Make sure you divide the entire left side. Okay. So then what does that give me? I have x minus 8 divided by negative 3 equal to y. So once we have y back by himself, that's how we know we're done. Okay, and we found the inverse. So I would rewrite this using inverse notation. F inverse of x is this equation, x minus 8 over negative 3. Okay. Now, one quick thing I want to point out really quick with your inverse function and your regular function. If you notice, everything is opposite. Their regular function has a plus 8. My inverse has a minus 8. Our regular function has negative 3 times x. Our inverse function has it divided by negative 3. So that's how you know if you did it right, if everything is opposite, inverse. Okay, let's go ahead and do B together. So I'm going to go ahead and start by changing this to y equals. Now, usually when we see parentheses, our gut tells us that we want to distribute that. But instead, I'm going to get rid of, actually, I have to swap my x and my y first. Jumping the gun a little here. So step 2 says switch your x and your y variables like this. Okay. Now let's go ahead and get rid of that 1/4. So again, I don't want to distribute this. I could if I wanted to, but actually I can get rid of this in one step if I just multiply by its reciprocal, right? So the opposite of 1/4 is 4/1. So that'll cancel that, leaving me with 4x equal to just y plus 12 now. Okay, because we canceled that out. So we don't really need those parentheses anymore because there's nothing in front of it. So last step, remember the goal is to get y by itself. So the last thing I'm going to do is just subtract that 12 over. Okay, and same thing, 4x and 12 are not like terms, so we can't really do anything with them besides write it as 4x minus 12 is equal to y. Once we have y back by itself, we know we found the inverse. So this is our inverse, g is -1 of x, and that function is 4x minus 12. So again, if I compare that to the original function, g had a plus 12, my inverse has a minus 12. My g function had a 1/4. This has a 4/1. So everything's flipped around and opposite. Okay, let's try maybe these last two. I might go through these ones a little faster now that we kind of got the hang of it. So I'm going to just start by doing this, kind of rewriting it, getting a little lazy here, but I'm just going to make that y equals, and then just jump to step number 2 where I interchange the x and the y. Okay. Now in this one, we're going to have to get rid of the subtraction first, so I'm going to go ahead and add the 5 over. Remember, our goal is to get y back by itself. So just recopying that. X plus 5 is equal to 2/3. Now we can do this in 2 steps, but it's a lot faster if we just use the reciprocal 3/2 and multiply that on both sides. Because then that just cancels that fraction right away. So now we have y equals, we have 3/2. Now it's times the whole thing, x plus 5, not just by the x, because the x plus 5 was there first. So when we multiply on both sides, we have to times it by everything. Now, if you wanted to, you could distribute this, but we don't necessarily have to. We can just leave it like this. So we have 3/2 times x plus 5. That is our inverse to the h function. Okay. All right, last one, we have j of x. So I'm going to change this to y equals and then switch those x and the y right away. Okay. Now, normally when we see a problem like this, we think that we want to always undo addition or subtraction first. But actually, I can't mess with this numerator because it's all divided by a 6. So in order to clear that, I'm going to multiply both sides by 6 first. So now I have 6 times x, that's 6x, is equal to 3y minus 2. And again, the goal is to get y back by itself, so let's add the 2 over first. That's going to give me 6x plus 2 is equal to 3y. So then our last step there would just be to divide that 3 out. And again, I'm going to divide it by everything. Okay, and if you wanted to, we could divide each of these and make this like 6x divided by 3 plus 2 divided by 3. Or honestly, you could just leave it. It doesn't matter to me. They're the same thing. So this could be an answer. Or if we wanted to simplify that, 6/3, that's going to give me 2x plus 2/3. So these are both the same answer. They mean the same thing. I would take either of them. If you submitted one or the other, they're the same answer, so that's fine. So going over the steps really quick, just one more time. Okay, we start by changing your function to y equals. Step 2 is to interchange or swap the x and the y variables, and then do whatever inverse operations you have to do to move everything back to the other side so that y is back by himself. Once you know you have y back by itself, you know you've finished the problem and you're done. Okay? So you guys are going to try some on the next page here on page 92 on the bottom. So 19 through 22. I'm just going to tell you to pick one of those to try and see if you can find the inverse for one of those functions. So whatever one you want to do, just choose one of them and see if you can find the inverse. See which one you like the best and give it a try. Okay, so depending on which one you did, here's the answers for all 4 of them. Okay, if you want to practice more of them, there's the answers there too, so you can kind of see if you can do it right again. But that's how we find inverse functions. So that's the final lesson for activity 6. We're not doing anything else. So that means we're actually done with Unit 1.